Welcome to the Material Minds podcast, the place where we talk to the people exploring new materials for a better world. Today we have a treat for you. We have Marc Schoeneich, an INM alum who's the founder of Innocise, the pioneers of the Gecomer technology. Gecomer technology, which is used to make adhesive pads that can stick to objects and move them around without any glue, without anything really sticky on it, just with microstructures. We talk about his technology, how strong it is, how much it can lift, how he stuck it to a rocket engine that was supposed to blast off any moment, and also about his journey from academia, from research, to becoming a founder of a company. It's a really breathtaking and fascinating conversation that we had, a lot of fun in it, and I'm sure you're going to enjoy. Let's go ahead. Hi, Marc. So, welcome to Material Minds. It's great to have you here back at INM.
Thank you for the invitation.
Yeah, it's so you have this company Innocise that you're running now. We're very curious to hear about that, but I'd like to get to know about you a little bit more. We're going to start off with
course.
3 truths and a lie.
Expected that.
Yeah, as always. So you're going to tell me 4 statements, as I understand. One is going to be a carefully crafted lie, I suppose, and I'm going to try to figure out which one that is.
I'm still crafting a lie. So.
Yes.
No, I'm a big fan of your podcast. So I'm hearing that, and I was feeling a little bit. Oh, I said okay. I need to prepare, but I didn't have the time to prepare. But I prepared a little bit. But your guests are really well prepared, and I was really like, okay, whoa, that's a high level to start off. But let me start with something scientific at least. So
Okay.
I think we're gonna go a little bit more into my background and probably the history as well. But starting with some scientific. So my first statement would be, of course, we're speaking about gecko structures. So it's we are direct jumping into the topic. And my first statement is based on nature, biomimetism, we are able to create adhesive structures, dry adhesive structures, so without no glue and nothing else, to pick up with 1 square centimeter, 2 kilograms. So it's a little bit vague, but if you transfer this, for example, to a €1 coin, you'd be able, with a surface of €1 coin, you would be able to pick up about 9 kilograms, which would be a gecko material going into contact with a dedicated. So let's assume that the surfaces are working perfectly together. So we are creating van der Waals interactions. 9 kilogram. So 9 kilogram would be like a 6-pack of water, the big bottles.
Yeah, true. Oof,
So that's the first thing. So we're able to build this here in Saarbrücken based on the technology.
That's the first statement. Okay. Does it depend on the material that you make your little gecko pad out of?
Of course. That's a rule of thumb. So the 2 kilograms is a rule of thumb. It's more a higher value, but we have proven that it's working at 2 kilograms.
Okay, so it's working for 2 kilograms for 1 centimeter squared. I think what I like better is your €1 coin. Lifting nine kilograms.
You gotta understand that. Yeah.
Lifting a
but
9.
When you draw, when you draw a square on your sheet and say, okay, this is 1 square centimeter. Then you can say, okay, that's 2 kilograms. That's quite enough.
2 kilograms is quite a bit. Yeah. Does the shape of the material you're lifting matter?
So I assume that the entire surface is in contact.
Okay,
So if for example, your gripping device, so the gripper is flat, so I assume that the surface is flat as well. So if you want to grip a bottle, for example, this means that in the best of the cases, the gecko surface follows the curvature as well. For the bottle, right?
Okay. What did you first test this on?
Where or
what? On what? Like, what did you lift?
Well,
to know
for
this?
us, honestly, the easiest surface to grip is always the smoother the better. So smooth means glass, for example, wafers, polymer films. But we have developed our own, and again, based on our research here at INM, our own like it's like a tensile test at the end of the day.
Yeah.
So that you put a substrate underneath, and you can look sometimes even through the substrate, and you can create like you put a gecko structure on top, and then you just lift it off and you measure it with a load cell.
Okay.
the force, and then you can calculate this back to the surface you're gripping. So it's
Okay.
basically it.
So it was a glass substrate probably at the
We
very
can say
beginning.
it's a glass substrate.
Yeah, okay. Okay. Is there a period of time that it can keep it held and lifted, or would it fall down after a while?
I'm a material scientist by training, but I forgot a lot of stuff. But but no, basically von der Waals interactions, and sorry for the listeners that I'm keeping stuff a little bit top level. But you say that as soon as you are in contact, the contact is just getting stronger. This
Okay.
assumes that, of course, that you have a right contact, so that you not have like a momentum, for example. You can imagine that you have like a part which is not, the glass is, for example, not a flat glass. It's more like something which is, the surface is probably flat, but the part itself has not, the center of gravity is not in the middle.
Uh-huh.
So you know that the part itself
Yeah,
gets
okay.
off after sometimes. But for example, at Innocise in the company, we have like a basketball net
Okay.
to play a little bit stuff like, and this it's on a surface since I think the creation of the company, so 6 years.
Oh,
And it's still
okay.
there. So
Okay.
and I did even here in my office, and we're gonna get to this point later on. And I even had gecko structures here in my office for years. So it's normally the force is just getting stronger. Of course, polymer
Yeah.
material science, we have a degradation due to UV and stuff like this, temperature, humidity.
Yeah.
Normally the adhesion force is just getting higher.
Okay. And is this your best material that you just told me?
The 2 kilogram per square centimeter is one of the best. Yeah.
One of the best. Okay. That is hard to believe, I have to say. I mean, I have seen
I have some
videos
toys
of
here.
things.
We're gonna
Yeah.
get into this later on, but
Yeah, maybe I kind of get a better feeling for it. I mean, I have seen some of the videos and some of the demonstrations and so
But
on.
for now, I leave it to this.
But 2 kilograms still sounds like something that, okay, it's a light dumbbell, right? Like it's very light. For a human to lift. 1 centimeter squared is really tiny, but when you put it as €1 and a 6-pack of these 1.5 liter bottles, yeah, that's a lot.
Yeah.
Okay, but let me think about it, and
right.
I'm curious for your second statement.
Well, the second statement is a little bit more about application. It was still at the time Innocise wasn't founded. So my task here at INM was to discover, develop the technology. So the technology fundament was there for decades, based on mainly Professor Art's team, of course, and his research. So my task was more to find a way to scale it up, and as well to find applications. So at the beginning, and we talked about that, it was more like hanging things on walls, so like the lights here or something like this, or posters. But of course, the question is what you would be able to pay for this kind of stuff, and if it's just coming out of research, and we're speaking about high tech, would you be able to pay like thousands of euros for that? Doubt it. So my task was to find applications, and I found one application which was specifically interesting, and this application was fixing sensors, so fixation of sensors on a rocket engine. So rocket engine from Ariane rockets. And as you know, or as you might know, so they are doing tests of rocket engines in Germany. The place is called, it's deep in the forest. So it's really like a small village, as you're feeling like in a James Bond movie. It's really like, so they have bunkers there because you can imagine when you fire up a rocket engine, stuff, so the entire mountain is vibrating. And so I had the contact there, and he said, Marc, can you just come in and because we have a test, and you might have like 10 minutes, you can climb on the engine, and you can bring some gecko structures with you, and we're gonna see if this is helping us to fit our sensors, because we keep on they're putting sensors on the surface around the housing, and they want to measure vibration, temperature, humidity, everything you can imagine. So I was driving there. And the thing was that the countdown had already begun. So it was like, engineers, it was like 10 minutes. Like, you said, okay, you have like 5 minutes, you can climb on a rocket. And I never saw a rocket engine. So I had the rocket engine in front of me, and I said, okay, you can put your geckos wherever you want. And what a lot of people not know is that the rocket engine itself, of course, it's getting really hot when you have the combustion, but the outside, due to the reaction of the liquid fuel, it's getting really cold. So we speak about
Oh.
temperatures of 50 Kelvin.
Okay.
So
Ooh.
this was a challenge for our technology,
Yeah.
and that's why they asked for some stuff.
Okay.
So that's the second statement. So I was working on a rocket engine and doing some tests before the company was created.
There's so many parts of this that sound like fiction to me. Like sounds like a James Bond movie to me already.
I can share more details. It's not a problem.
Yeah, I'm gonna ask you some. So maybe the first detail, what you talked about actually, like the temperature, right?
Yeah.
Can you maybe tell me a little bit more about? You said it through van der Waals interactions.
Yep.
How the Gecomer technology actually works and how it manages these temperatures.
Yeah. So we are just speaking about contact. So everything is about contact with the gecko. So van der Waals interactions, molecular forces, and honestly, again, sorry for all the listeners being more deeper into this stuff. And I was really deep in 2017, 18 in this story. But again, I like to more explain this to a general audition of people. So it's okay. I'm always, and sorry again, I'm saying, well, it's like a magnet, but it's working for every material.
It's like a sorry?
I like a magnet.
Magnet, yeah.
But it's, of course, we have a molecular orientation of
Yeah.
the atoms, and you're getting attraction by H bonds. So you're getting this kind of molecular forces. But the thing is that, so again, you bring two materials together and they stick. So, and that's why I'm saying it's magnets, because you don't have like glue or something else involved. It's just two materials attracting each other. The clue or the specific well, the issue you have with this kind of adhesion is that you're, and that's always like what I'm explaining. I'm saying this sentence nearly every day.
Okay.
So imagine you put your hand on a table. You have the impression that your hand is in contact with the table. But in reality, it's just like 1 or 2% of the surface of the hand which is in contact, because, well, the table is not flat.
Yeah.
Under a microscope, your hand is not flat. You have grease on it. Just like coffee, you had pizza before, you have grease on it. So it's absolutely not in contact. And what a gecko is able, due to his small and tiny microstructure, is to create a contact which is on a microscopic level, really following the roughness of the counterpart. So what we are doing is to create microstructures which needs to follow more or less the roughness structure of a part. So you really need to go into contact. So you really need to be close, and not like putting things on a table close. You need to be close to the roughness profile.
Yeah.
And you can create the structure. It's really like the power. Well, if you follow the equation based on van der Waals interaction, so it's the distance from the part you want to grip. Is so the adhesion force scales with the distance to the power of 6.
Oh, 6. Okay.
So you can imagine that even if you have some dust in between, some grease, some distance due to a hair or whatever which is on the table, you could directly lose the.
But temperature doesn't matter?
Yeah, temperature. Then we are going to the other side. So now I was speaking more about the microstructure. When we speak about temperature, it's more about the polymer and the gecko feed itself.
Okay.
So because as we know, we have thermoplastic materials, we have elastomers and so on. So if I'm having a temperature environment, we're speaking about higher temperatures, of course, the thermoplastic material just would melt away.
Yeah.
So it would glue once very good, but then you can lose it. So it's more like a chewing gum. And if you're getting colder, of course, you need to be aware of TG. You need to be aware of what's happening. Does it getting brittle, or how does it have an extension? And normally you don't have like only one material, so you have two materials. Is it like a bimeter? So do you have like a curvature occurring to the cold temperature? You really need to think about the material. So, and not to lengthen this up, but it's what we are doing at Innocise at the end of the day is really that. So we're directly coming to the core, because we are experts in material science, so polymer science, and microstructuring. And only by bringing these 2 points together, you are able to create a system which works in the industry and even for different applications. And
okay, so now in this rocket example,
coming back to the rocket, of course.
You found a material that doesn't deform or has the same kind of expansion or bending or whatever at minus or at 50 Kelvin.
I didn't found that. I didn't find it. It was like really research. So I had in German you call it Bauchladen. So I just bought everything I had.
Okay.
I bought everything I had at the time. So we did a lot of structures, PDMS structures here in the lab. We did foils with the imprint machine. We did like some first tests with thermoplastic material. So I just bought everything I had, and I had 5 minutes to bring it on somewhere on a smooth surface on a rocket engine.
Okay. And was the stuff supposed to stick also when the rocket got really hot?
It's just getting cold. So the place where they wanted me to stick the stuff, it
Ah,
was
it's
just,
only
it was
okay,
just
okay,
50,
only the
just
cold.
50 Kelvin, yeah.
Okay, yeah, okay, but it was supposed to work at the very low temperature.
Yeah.
Okay, the last question on this for me
Yeah.
is, did it work?
Well, the answer is yes and no, because it's getting really, so everything is vibrating, and I was like a little bit after the test, I needed to find back to my structures on the surface. So I was looking for them, so some parts fall off due to the brittleness of the polymer at the end of the day, so it got brittle. But I had one structure which was a 50 microstructure, so we call this 50. The hairs are 50 micrometers thick, so it's our nomenclature, which was still working.
Okay.
So we found one which was doing the job as
Okay.
expected.
As an application you're pursuing.
This is nice, and it worked,
Uh-huh.
but we never sold one part. Again,
Okay.
again, it's a question of market, and probably we can come to this later on. But it's so if this would be interesting for a company to sell, they just need 1 or 2 a year. So it would be like
okay.
I can sell them for, I don't know, 50,000 euros, but
Yeah.
not so. So it's, it's a facility, and you can look this up on the internet. It's really interesting.
Uh-huh.
And it's a facility where even the truck driver has a PhD. No, it's
okay.
it's really like it's a place where it's scientific.
Yeah,
it's not
I
it's
haven't
not like
heard that much
CERN, but
about
it's
it, yeah.
really like it's really an interesting place to be and to make some tests. But yeah,
Fascinating, and could very well be a lie, but yeah, let me think about it. Let me hear your
Right.
third statement.
Third statement. Third statement. A little bit more about my life here at INM, because it's interesting probably for the listeners as well. So I did my PhD in material science, plastic polymers, short fiber reinforced polymers, not at INM, and so it was kind of a postdoc I did here. So I came here after my PhD, and I never, during the entire time I spent at the INM, I never wrote any paper, any book, any contribution. So you can look this up. I did not write anything, which is really unusual for a researcher at this time, right? So,
Yeah.
and I think this could be a bridge as well to the topic about what you need to do if you want to spin something out. So I was so occupied with other stuff and never wrote something.
Okay, so you were at Leibniz-INM, Scientific Research Institution, in
I'm
Germany,
honest, yeah.
and you did not write a single publication, even though actually you have this really cool technology, you were doing really cool stuff.
Because it was supposed to be already done. So
Yeah,
we said,
okay.
the research is done, it's just application.
Yeah, okay. Did you patent stuff in that time?
Is I what? Sorry?
Did you make patents?
Patent. No.
No.
Not at all.
Okay.
No.
So
Because if you make a patent, then it belongs to the to the university or to INM, and if you want to create a company. But again, there's so many things to speak about. But it's, at the beginning when I started INM, I wasn't supposed to create a company.
Okay.
I was not like coming to INM. No, now I create a company.
Okay.
So it was a process over 2 years. Yeah.
So that means you would have still thought in the scientific direction, publishing a paper and so on, but your path changed.
I said if I work here, my task would be to bring this technology to the market. If I would be part of bringing this to the market after the INM, I didn't know that. So there were a lot of plans, a lot of ideas, but at the end of the day, I was not here being, I will be the future CEO of a spin-off of INM. I said, okay, my task is as an upscaling manager, whatever you call it. You can call yourself whatever you want nowadays, right? So that's not, it's just to look for, so 2 tasks: look for applications all over the world. I was traveling a lot, and find a way to make this work all of the time. So you know what I mean? So you have one batch, it's probably working, a guy in the lab with a security code and goggles and so on is doing some stuff, and it works. But can you remember how you did it? Did it work?
Yeah.
No. So let's start again next time.
Yeah, that's way too familiar. Yeah.
And it's research, of course, but my task was to bring this to a stable process where you said, okay, I can, at the end of the day, push a button and just get 1,000 a day. Which,
Yeah.
of course, is for a research institute not exactly the way to go, but you need to think about this before you create a company. Because if not, you say, imagine a customer coming around saying, hey, I want 1,000 of these. And you can say, yeah, I can give you 10.
Yeah.
So
Yeah.
it's a little bit complicated, yeah.
Okay.
So no scientific publication. There might be a talk left or right, and
Okay.
but yeah.
But you were going, so when you said you were traveling a lot, were
Yeah.
you going to industry fairs or was it like conferences? What is it like?
Fairs, a lot of fairs to understand the market, to understand the needs, and I'm still doing this every week, is going to customers. So from my point, I now say customers from.
Sorry, but you
from
didn't have a company at that time, so.
No, but
what
yeah,
was
so
the-
that's why let me explain. So it's not like at the time I didn't call it customers, I called this potential partners
Okay.
for projects. So like now, if you're looking for third party funding from a company,
Mhm.
so you go to a Saarland company for, I don't know, pizzas in your RAM. Say, okay, can you make a project so that you
Yeah.
pay us some money for doing the tests, and and I was like trying to open, and that's again what I'm saying every day, putting new seeds into the ground for the technology, and then water them every
Yeah,
day
okay.
to see where
that's-
some potentials are growing. Yeah.
That's a nice metaphor of that. Did you apply for third-party funding in this sense, like innovation related?
Yeah, we always had projects running. So I was
Okay.
involved in projects
Okay.
already running when I came. We were doing follow-up projects. We are doing on a lot of different stuff. Yeah.
Okay, so it was almost like an industry R&D sort of job that you had
Yeah.
here with no
Yeah,
publication.
sales as well a
no-
little bit. So
and
sell
okay.
INM, sell
Yeah.
sell
Yeah.
INM, sell the technology, trying to attract even finding funding.
Yeah.
For a future company, but funding as well for pursuing the technology.
Mhm.
So we know, as you probably remember, we had the showroom at the
Yeah.
ETH over there,
Yeah.
and trying to bring politicians in to see how things are evolving,
Yeah. Okay.
and you can imagine that there was no time, and I was not like saying no, I don't
Yeah,
want to
yeah.
write scientific publication, because I was just coming out of my PhD, and of
Yeah.
course I wanted to write, and I was trained to write stuff and to do this, but
Yeah.
just simply didn't have the time.
Did it frighten you at that point a little bit that, I mean, for an academic, oriented person, like if you're not publishing in a year or so, it starts getting a little bit scary?
Not really.
No. Okay.
Not really. So I just followed what I wanted to do.
Mhm.
So that it was really like that. I didn't said, well, I want to do this. I want to create something. I want that's my job, and I want to build this. I want to make the bridge. I really want to make the bridge between the technologies. This is called technology
Yeah.
transfer. So I really want
Mhm.
to, and I don't want to stop in the middle, because I'm
Mhm.
jumping over the cliff, and I cannot stop. So I'm
okay.
doing this. And I felt as well when I got the job at INM, funny story as well. I don't know if we have the time, but
Mhm.
if we for me it was like I did not want to work in industry, because I want to have the freedom. I want to have the freedom to create something and to build something up, not from scratch, because the technology was there, the IP was there, all the research was there, but to build something, to bring something. So even doing my PhD, I said I want to put something on the table in the end of my PhD. I did
Yeah,
not want
okay.
just to have a model, which is of course really important as well,
Yeah.
and which is then just locked up in the bin. So I want to. It was always my motivation. So
Okay.
I was really happy with that. And in the end of the day as well, after I created the company, I had different people approaching me, even it's mainly from my scientific network. Mark, I think you should consider applying for this W3 position over there for
Okay.
professorship, because you did. And I always said no.
Okay.
I cannot do both. I really dedicated to this, and
Okay.
I owe this to my team and to the technology, and that's why I said, well, that's what I like.
Okay. Very interesting.
Okay,
And,
again, we derated a little bit in another
No,
direction,
but I mean, yeah, it gives me the
sorry for listeners.
context, and again, makes it sound very real. Of course, keeping in mind that one of these is a lie.
I
So
still need to find a lie. Yeah.
uh,
No.
But yeah, all of these. Well, the rocket so far sounds the most outlandish
Okay.
so far. But let me see. Let's
Yeah, the
hear your
last
fourth
one
statement.
is probably, let's make it a little bit shorter. The last one is related to the third one. It's to my life here at INM when I was working here on a daily basis, and it was, can remember it was really nice always to come here by bike and so on. So it was nice time.
Okay.
My favorite place at INM
Uh-huh.
where I worked, and my favorite place at INM was my office,
Okay.
because it was like the how to say, it was like the center of gravity, center of gravity of my work, because I was in a normal 4 people, I don't know how it's now nowadays, so 4 people office, which was really like crowded, but it was always like somebody coming in, throwing a new idea.
Yeah.
Another guy close to me just finishing his PhD, crying every day, writing down the final things.
Yeah.
And the thing. But it was really like my favorite place to because I had, of course, a chance to supervise a small team as well.
Yeah.
So students coming in and running out.
yeah.
So it was really like a place where I could try stuff. And the first videos which I sent to investors and potential customers, I did this on this table where I worked. And I just had a small gecko material and said, look, this is working, this is working, and so on. So I had a special dedication to this place.
Okay, so your favorite place was the office. And I can relate to that a little bit because I was also postdoc here before I got my group. We had this 4-person office and so
but
on.
it's more the environment. So it's not, I didn't enjoy the table or the computer, but it's more like the
people and the vibe around it. Yeah. And I can relate to that because, so I was also in one of these 4-people office and
it's hard to stay focused, but
yeah, that's true. But when you're working in the lab, especially, then every new idea triggers you. You can do something. You actually have the time to go after it. I mean, now I'm in a 2-person office, luckily sharing with the person behind the camera now, Lars, and we do come up with some ideas. But it's a different vibe for sure.
Yeah.
So, but whether that's your favorite place, because you were doing a lot of R&D stuff, you were doing, a lot of Gecko stuff, of course.
But never alone, It's always like with people. There's always people involved. There's always people around. Some people stayed with me. Some people came with me to start Innocise. So there's a lot of different people.
Yeah. So a lot of connections that you made were in that office then. Okay. Interesting. Let me recap your 4 statements and then try to figure out which is the lie. First one is 1 centimeter squared lifts 2 kilograms, or €1 coin size Gecomer pad lifts a 6-pack of 1.5 liter bottles. So 9 kilos. The second one is a rocket James Bond mission.
Exactly.
Basically, the third one was
no papers.
You didn't write a single publication or a single chapter or anything like that during your time here. And the fourth one is that your favorite place at INM was the office. My gut instinct is still the rocket, although I very much want that to be true.
Your choice.
But I'm gonna go with the rocket.
Okay. I'm sorry, but that's not.
That's not.
That's
that was true.
That's
okay,
true,
that's bittersweet. I mean, I did want it to be true. Like, okay.
That's true.
That's true.
I even have some photos somewhere. So yeah.
That is fascinating. Okay. Then we got to get into that a little bit more. But
I don't know.
Okay. Then is it your 1 centimeter square lifts 2 kilograms? No, that's true.
Yeah.
So the most outlandish statements are all true.
Yeah.
Okay. So then your favorite place was not the office?
That's right.
Okay.
Well, there wasn't a big choice either.
Yeah.
But
okay.
I never. Well, of course, I like the people. That's not so. Everyone hearing that, sharing the office with me. No, I really like the people, but I prefer, and that's what you kind of know about me right now as well. So I like to be out there. I like to be in companies. I like to need to be on planes, traveling, meeting people. So my favorite place at INM was the lab. So being in the lab, doing stuff, experiencing things, making some accidents, which led to great things. And being at ITSI with the machines, with Martin in the mechanical workshop. So mechanical workshop was at the time I just overflowed them with things. So
Yeah.
because they were happy, but because finally somebody with a mechanical engineering background asked them stuff to do,
Yeah.
and so they were. It was like, and I'm still with really good contact with the people working who worked over there. So yeah, for me it was more like getting my hands dirty.
The lab, yeah, okay.
And not sitting in front of an office desk.
Oh, I should have guessed that. Well, if I knew the first, at least if I knew the rocket was true for sure, then I would have guessed the office is
Yeah.
definitely not your favorite place.
Yeah.
But okay, you got me.
Yeah.
You're the second person who's got me.
Really?
Yeah.
Yeah, well,
in
I was listening,
the
but okay,
podcast.
yeah.
Yeah. So,
No, you're really good. That's right.
well, I get lucky for sure quite a bit, but
Okay.
well,
Yeah.
yeah.
Yeah, so sorry for the statement. So a little bit less scientific, but
No, I mean
think
it's completely fine. Like it's supposed to be very open, and it's supposed to tell me something about you, which
Yeah.
I think it reveals very clearly. Maybe let's. Normally at this point, I kind of segue to your favorite material, but I think this is
whatever
kind
you
of
want.
obvious. But I'm gonna then link it to your 2 kilograms, your first
Yeah.
statement, basically, right?
Okay.
And you have some materials
Yep.
here. Maybe you want to tell us a little bit about it and show me a little bit about what you mean by lifting the
Yeah,
object.
yeah. That's what we can
so
what we
on.
can do.
Yeah.
So probably to stay in your questions, and for the listeners as well, it's always good to have like a red line to
yeah.
follow. So of course that's easier. My favorite material is polymer. Yeah, are polymers, plastic materials, so everything which is related to that. So in my PhD, and I just bought it that you get an idea. So I was more like working on structural parts. So what you see right here is a brake lever for bikes.
Uh-huh.
So and
lift it up a little?
my task was to, so if you have that's a standard bike lever here, metal.
Uh-huh.
So that's
It's a cycle.
yeah, some
brake.
cycles
Yeah.
for bikes.
Yes.
So that's my motivation as well. So I used to bike a lot, even to I&M. So we have like this lever, and well, this is an aluminum part, which is normally a little bit heavy, and so it was like to create structural parts, lightweight parts, but which are even stiffer or even stronger than an aluminum part or something made of metal. So speaking about lightweight, so for example, pedals for cars, they're nowadays even the brake pedal, for example, they're made out of plastics.
Okay.
Yeah.
Uh-huh.
So brake pedal just in a Porsche because that's a little bit more expensive and so on. But
Yeah.
if you're checking out your new car, so the pedal to change gears made out of plastic.
Okay.
So my task was to find a way to better simulate the behavior of this high tech polymers, so thermoplastic materials which are reinforced by glass fibers.
Okay.
And so I did a lot of numerical modeling and creating modeling of and improvement of how structural parts could look like. And so I did so material models basically in France, and then I did all the tests, and you see some results. So this is, and we're coming to our geckos, don't worry.
Yeah.
So this is, for example, so this is 3D printed, what you have in your hand, and what you see here, that's injection molded.
Okay.
Difference between injection molding and 3D printing is fast, but injection molding is faster as soon as you have the mold.
Yeah.
So we speak about, for example, caps for plastic bottles.
Yeah.
So there are machines, they're producing hundreds of them in a second.
Okay.
So it's really, really fast, and 3D printing.
So
everyone
what
does
we're
3D
just for the
printing.
listeners, what we're holding up is like a cycle
brake lever.
Yeah, cycle brake lever
Yeah.
that you hold up, but it's made 3D printed basically.
Yeah, this is 3D printed, and I have
And
the
the other
same
one
thing,
is-
which is
yeah.
made by injection molding. So my task was to find a way to improve structural behavior of composite parts at the end of a composite, but not like in a random shape, based on information you get out of the material. And that's why I developed specimens to test the material. So that's a tube specimen I tested. So it's just looking like a small handle.
Okay, yeah,
For
a
the-
small
for the,
handle
for the
that you
listeners.
have.
So it's different, and you need to think about how to create a part. So you cannot, the part is injected, so you have 2 injection points on top, and then the part goes in with a high pressure, and you fill this up. There is an old injection molding machine at I&M.
Yeah.
So, and I came to I&M and said, well, does anyone thought about doing injection molding for the gecko structure? And that's a little bit the link from my PhD to the gecko structures. So we're producing them by injection molding nowadays. So
Okay.
because really fast, reliable. So what you see here, and then we switch from my favorite material, a little bit about PhD stuff. So to the gecko material.
Yeah.
And I always choose this kind of microstructure and material combination to show somebody for the first time, because you can still see the hairs. So that's what I already explained, is that we are experts in the microstructure and in the material. So our hairs getting, so the microstructure of the it's getting so small that you cannot see it anymore with your eye. So it's getting, we are speaking about a microstructure which has like a single digit micron size.
Single micron.
Yeah, single micron
Yeah,
size.
okay.
So we speak about like 5 micrometers.
Okay.
Which is possible.
Okay.
But at the end of the day, if you show this, it just looks like a flat surface.
Yeah,
And you say, I just need to tell you why you need to trust me, because the surface is just not.
So it's 20 times smaller than a human hair, basically, or it's like a few bacteria wide.
Yeah.
For example.
And so this one here is a thermoplastic material, which basically is still the same material as I started to develop here at INM. So 6 years ago. And we have like the hairs, and you can touch it. It's not a problem.
Can I have a look?
And of course, for the haptics people, this is really nice as well.
Yeah.
because you can touch
So
it,
I'm
feels
just
nice,
touching
and-
these little hairs on top of the
and it's
Gecomer pad.
yeah, and you feel it's not sticky, right?
Yeah,
So
it's not at all.
sticky at all. So it's just
Yeah.
like a simple polymer surface.
Yeah, it's just like a rough sort of brush type surface.
But you see when you look through the light a little bit, so that it's not like just a pin array. So it's really like a specific shape, like a trumpet-shaped microstructure with a mushroom-shaped structure to create this kind of adhesion. Because, as we learned before, we need to go into contact with the part.
Yeah.
And this is made so you can imagine right now, getting a little bit more into the science, is that you can imagine that the bigger the hairs, the smoother the surface should get. Because if you're getting the roughness profile and you're having like a big polymer stamp going on, so it doesn't work that good. So you can imagine that this structure is more made for smooth surface, like glass. And we are really lucky. So I have some glass with me here today. Yeah, so I was just finding this in my. No, honestly, so I have this demo case, and I can show it to the camera. So this demo case, I have this beginning of the company, which is really, really nice, because I carry this everywhere. So I put this out in Berlin at 2 o'clock in the morning in a bar. I put this everywhere. So I show this to everyone, because that's what I was telling you, putting seeds into the ground. So you always need to speak to someone. Say, you never know, you might have an idea. The listeners might have an idea.
Yeah, absolutely.
So I have a glass here. And so this gripper is specifically made for a smooth surface like glass. And what would happen is, that's not a surprise,
It lifts it.
it lifts it up.
Yeah.
What you can see in the glass is really nice as well, because you can look through it, so you see where the contact has occurred.
Okay.
Right? So and of course, as my hand is not that precise as a robot or something like this, you see that there are always areas which might be a little bit uncovered, because the polymer is a little bit. So we have a Shore A of 65. So the material is not that smooth, like a chewing gum, or like a really smooth or really smooth BDMS or whatever. Soft.
Yeah.
So well, this is sticking,
Right.
and exactly what you're doing. So you said, "Hey, can I touch? I need to touch it." So what you see, just give me 1 second, so you can look a little bit through it. And so here we have a surface which is a little bit about 5 times 5 centimeters. So based on our calculation, this should be a lot.
Yeah.
What I can already say is, so this microstructure with this glass, we speak about 1 kilogram per square centimeter, which still is a big bag of cement. So 25 kilograms. So what you can try is get this off. You will get this off.
Okay.
So just take care, because I had already a situation with a customer just ripping this off, and the glass was was like flying over the room. And what you do by instinct as well, and that's the thing. So you by instinct, you're not putting this really parallel into the opposite direction.
Yeah.
You're just moving this a little bit, and this helps you, of course, to get rid of it.
Okay.
So if you have like a momentum creating on the hairs, they will buckle. So they will like making a movement. So you go into contact, and they will just bend a little bit, because the gecko needs to get away from the surface as well. So that's how he does it. And so but it's good to get just an idea of.
Yeah.
Can play around with it.
Really nice. Yeah, so I've got this Gecomer pad attached to a glass block, which actually I'm pulling pretty hard. Oh, yeah, finally I get it off, but
Yeah.
probably because I twisted it a little bit.
But it's supposed to go off, so that's all right.
Yeah.
So but you can feel
I can
feel
feel
you can feel the
how-
strength,
yeah.
and makes a nice noise as well.
Oh yeah, that's true. This is for ASMR, for our ASMR people, you know, like
Yeah.
there we go. That's
Yeah.
the sound. Wonderful, yeah. And yeah, when I press it against the pad, I can see regions that look different from the others.
Yeah.
And I think that suggests where there is contact, where
Yeah.
there isn't, right?
And what you see as well, of course, is right now is that when you touch it, of course, you put grease on the surface.
Mm-hmm.
So this means that you're losing a little bit of the adhesion force. So,
Mhm.
but you always can clean it. So I have this gecko structure for years in this small suitcase,
Nice.
and it's always working. Yeah, so
that's
that's
incredible.
and that's basically the stuff we are doing.
Yeah,
Of course, we say we create fingertips for robots, but at the
Uh-huh.
end, it's the last millimeter between an object you want to lift up, you want to move, you want to stay into place,
Yeah.
and the holding system, the robot, whatever.
Mm-hmm.
And what we do, of course, as well, or what we do is that we see that there's a lot of, and I'm not sure if you're using this at INM, but we selling this to a lot of institutes, is
Mm-hmm.
that we are building out of these materials. We are building like a gecko pens,
Okay.
but you cannot draw. It's more like it's more like a tweezer
Uh-huh.
for lab applications.
Uh-huh.
But it's like a pen, so it looks like a pen.
Okay.
So you see, it's just basically the same thing we just saw. We have
Uh-huh.
a holding structure,
Uh-huh.
and on top we have a tiny microstructure. And here
Yeah.
you cannot see the hairs anymore. So we
Okay.
speak about 50 microns.
Okay.
And this is used for picking up small objects in the lab. So when you have like tweezers, for example,
Ah.
steel bolts,
Yeah.
the
Okay.
small round, we always or diamonds or glass fibers or sensors, whatever. So
Yeah.
so we have a lot of customers using this for pick and place
Yeah.
situations to grip and place small things.
That's very cool. Can I have a
And
look?
yeah, of course.
Yeah, so what I have is basically what looks like a pen, but the top of the pad is, yeah, I can't see the microstructure. It is one of these gecko pens.
We are lucky. I have a small lens here. That's a bigger. So
Oh,
we
that's
have
a
it.
bigger
We have it.
one.
We have it in
Okay,
three. We
different
have it three.
sizes.
We have three sizes, two different microstructures. So that's an idea. So because I'm trying to come a little bit from the material to the product. So this is a
Uh-huh.
product. So it has a product number. It has a name Innocise on
Nice,
it. It has
yeah.
a number. It has a packaging, QR code
Mhm.
on it, and everything. So you can buy this out of stock. So that's a standard.
Nice.
So that you see that where we are coming from, and that
Yeah.
you're having a product. And I have a small lens now for the cameraman. It gets a little bit more. So you see that I'm gripping a small lens. You can
Uh-huh.
check
Yeah,
this
yeah, that's true.
with the gecko. Of course, this is still a big one, which could be done manually. Play it. Normally, this should not working because
No, okay. I'm trying to
the
pull
surface-
this little lens from one gecko pen to the other, but okay, that
No.
doesn't work. So it's stuck really well.
yeah.
Oh, no, I got
That's
it.
great. That's
Yeah.
great.
Does this
Good
have
idea.
smaller microstructures?
I
in
need to
this
check.
one?
I need to check. It could be that they are different. What's the color at the back of the pen?
Green and also sort of green.
Yeah, but different. So
Different
that's
green, right?
green and yellow. It's green and yellow.
Green, okay.
Now we found out that.
Okay.
So that's that's another microstructure.
Yeah, the green
Yeah,
is
never tried this before.
Okay, interesting. Wow. Material minds first. From one gecko pen to the other.
Yeah.
Oh,
So-
no, it went back to this.
okay.
Okay, interesting. Nice.
Yeah. So and you can change the angle. So we use this for normal
Yeah.
manual work, and you would be surprised. So I was surprised because there's a lot of, and you speak about production industry where we are mainly working.
Mm-hmm.
There are a lot of things still done manually.
Mm-hmm.
So, of course, all these watchmakers,
Yeah.
Switzerland, all the small parts. There's so many things still done by hand, especially when you're in prototype stadium of parts.
Mhm.
So, and this is for us opening. It's again the seed which I can
Yeah,
put
yeah.
to the ground, because then the customer or the institute, they already know a little bit, because it's easy to explain,
Mm-hmm.
but it's hard to implement because it's different. So
Yeah.
you're touching this right now, you have grease on the surface, and then it's
Yeah.
not working properly. You say,
Yeah.
it's not working. So what are these guys at Innocise doing? It's not working anymore.
Yeah.
I'm just asking you, what did you do?
Yeah.
So you get a little bit, you can play around and you
Yeah.
can say, oh, well, this is not working, this is working, why is this working in this situation, why is it not working in this situation?
Yeah.
And then you can think about automation and putting this
Yeah.
to an assembly line for whatever.
So do you have like a little cleaning tool for this?
Yeah, I
also
haven't
to
this
get some
today, but
s-
we have, of course, a standard
Okay.
manual cleaning tool. We have in robotic applications, we have like carpets, we
Yeah.
have rolls.
Yeah.
We
Okay.
can, so we should avoid, and we have customers, of course, they try to clean it with acetone. So
Yeah.
acetone
Okay.
said
That's
that
not
it
good,
was really clean, the gripper was gone as well.
Yeah.
But still,
okay.
that's something you can clean. Yeah, it's always the question which is coming up, of course.
So
You can clean
that's
the
really interesting. So I mean, you gave us the example of the rocket that you tried out, but of course there wasn't a great market for that. And
Yeah.
but these are like product ideas that I would have never thought of, right? Like I
Okay.
mean, not obviously at
Yeah.
least. I mean, the robotic handle is what I could directly
Yeah.
relate to,
Yeah.
of course. But these kind of pens and so on, and where exactly, like with the watchmakers and things like that, these are very unique sort of angles that you can only identify when you go talk to people, when you
Yeah.
go meet them, and like planting the seeds
Mhm.
of innovation. Can you say anything of what is in development right now, or if there are some things in development?
The company.
co-
we are in continuous development.
Yeah.
No, there's so many things. So you should think of that. We at the beginning, of course, and still at INM, it was that I said, okay, and all the team said we need to develop this and that. We need to be more reliable. We need to produce always the same quality and stuff like this. And we said, okay, we need, for example, if I take again this gripper here, it's really important for me as well to show what is not working. So this gripper here, I have paper here.
Yeah, so the big flat pad.
It's not working.
Yeah, it
it's
doesn't
not
work
working
with
at
paper.
all. So
Yeah.
because it's too rough in terms of. So I said, okay, we need to develop a specific standard range of different microstructures and materials to give a customer calling us an idea what is possible and what's not possible. So we did a lot of development of microstructures and materials, according to as well customer specifications like FDA, so food grade, so that you're not so when you're speaking about life science pharmaceutical applications where you're not allowed to touch the product because you get you guys know this better than I do. So that the gripper is really clean and made out of a clean material that you're not having outgassing properties and so on. So that's something we did a lot at the beginning. Right now, it's really, really application specific. So for us, it is I I cannot afford to say, okay, I want to develop this, and this. So it's really it's another way of thinking. Of course, at a research institute, you say, well, I have an idea. Of course, you have always a frame, and you need to get funding as well, and so on.
Yeah.
But for us, it's the funding comes from the customer. So if I'm getting a request for wafer handling, for example, wafer, you know what a wafer is?
Like a silicon wafer.
A silicon wafer.
Yeah.
So it's basically the most, what to say, it's the basic product to create all of the chips which are around us.
Yeah.
So and this kind of wafer spends 3 months in the fab. So before chips are on the surface, and we have more than 1,000 gripping and holding applications.
Okay.
So that's an application when the customer comes to us and says, hey, we heard about your technology. Can we use the Gecko for gripping wafers? I would say, well, this is worth a development, and then we are getting specific and again, it's coming all back to materials. Material specific requirements like ESD, so conductivity, so that say, okay, we need to conduct the electricity back from the part, or we need to have this kind of heat or outgassing properties. We are still measuring stuff here at INM to. Of course, we pay for that. So measuring properties and getting a gripper which is related, or which is following the specifications from the customer. So development is, from our point of view, always something. It makes no sense to create a part and then the customer is saying, well, you have created a yellow part, but I wanted to have a green one. Or it's always a little bit like depending on the requests we get. Of course, sometimes we get requests, and I could have put this as well in the statements at the beginning. So like the rocket.
Yeah,
I said okay,
exactly,
the
yeah.
rocket, but this was before the company. But still, things so bricks or Swiss cheese or chocolate or stuff like this would have said, okay,
Yeah.
this is not working. Yeah.
Yeah. Okay. Wow. So, I mean, normally around this point, towards the end of the episode, I
Mhm.
ask about the future, but I think you've already given us quite a glimpse into the future with your James Bond rocket things and your gecko pens and so on.
Yeah.
Maybe I want to then actually end on the point of your third statement, sort of
Mhm.
like going into that a little bit, that you didn't do any publications and so on
Okay.
here.
Yeah.
You're focused on basically making this product. What does it take to take a technology that's been developed in an institute and then make a business out of it, make a product out of it, and be out there
Mm.
selling something?
My straight answer would be time and money. But it's probably a little bit. It's a little bit. But at the end of the day, it's true.
Mhm.
Yeah. And honestly speaking, so even and of course, I never created a company before, so for me it
Mhm.
was the first time as well. And the entire team and investors, we all thought it's gonna be really, really fast. So we said
Mhm.
at the beginning, well, we have already industrial partners and customers. They want to buy the stuff, so they're gonna buy it, and we're gonna make a lot of money in terms of to pay the company. So for me, it's
Mhm.
not like for me a healthy, and that's what I want to build for the future as well at Innocise. So having and what we're still since day one working on a healthy company, not in terms of healthy means that the company is rich, but healthy for the people working there as well.
Mm.
So coming back to your question is to you need to have a commitment. You need to have a
Mhm.
team who is really willing to do. It makes no sense to say, okay, to say, okay, you guys, you and you, now you're gonna do the spin-off thing, and because you haven't been on the tree by the count of three, so
Mhm.
you guys need to do that. You need to have commitment. You need to really say, okay, I'm not doing things in parallel and doing left and right stuff. You really need to be focused on the stuff. So that's most for me. That's the most important thing.
Okay. And when did you make this choice of becoming a CEO and getting into this? Was it at the end of your time here at INM or
It's a
already
little bit
during?
it's a little bit a commitment. So of course I cannot share all the details which occurred, but for me it was really the commitment I had towards the technology, and it was how to say. So as I said at the beginning, probably I was responsible for finding applications and scaling up the
Mhm.
technology. And one point in time, I realized, okay, check. So I have an idea in mind where we can go. I have some
Mhm.
customers who said, well, who might be willing to spend some money on that.
Mhm.
Okay, I found a way to produce this kind of cheap and kind of reliable.
Mhm.
So please let me out of here. So
Yeah.
I really
Okay.
said to anyway, so I need to go out of here. I need to create something. I don't want to be in the restraints of a research institute, which said, of course, we have a liability. We cannot just sell stuff to companies.
Mhm.
So I reached a limit where I couldn't act
Mm.
inside a research institute, and I said, okay, I
Mhm.
need to go out. I need to spin off. I don't want to have an office at INM. I need to go out, and that's the point where I decided for myself as well. I don't want a backup option. I really
Mhm.
want to do this. So please let me out.
Yeah. Okay. So you had this itch, you had the
Yeah.
drive, you had the
Yeah.
commitment,
Yeah.
and we need time and money
Yeah.
to make
Yeah.
these wonderful technologies that we're creating here into reality out there for society.
Yeah,
And
and the most important thing is the team, right? So I
and a
mentioned this
team.
at the beginning.
Mhm.
So you need people working for that, working on that, being motivated 150, 200% every day, and that's
Mhm.
what we have here in Saarbrücken, and that's what we had at INM as well. Several people came, and that's a big thanks to INM as well. So without
Mhm.
INM, this wouldn't be possible. So people were willing as well to follow and to start and to jump over the cliff or into the cold water or whatever you want to call it,
Yeah.
to say, okay, I want to go out of the institute instead of, for example, continuing my PhD
Yeah.
or being in the safe space of INM, having my paycheck at the end of the month every month. So willing to jump on it and jump on the adventure. So if you like something, where you say, okay, always some excitement about research, it's all right. But if you really want to have like a roller coaster,
Yeah.
that's that's something for you. So if you think about, okay, I really like to have days where nothing works, really nothing. So it's really bad, and then the next day it's like bright sunshine, and that's fantastic. So that is
That's
the
a
the
that's
life of a
reality.
young company, and
Yeah. That's great,
yeah,
and I think that's an excellent note to end on. At the
right,
start of the podcast, we usually introduce the podcast as the place where we talk to people exploring new materials for a better world. And you found those people, you
of
made that
course,
team,
yeah.
and yeah, you have this beautiful company making these really fun products.
I'm really grateful for that.
And I had a really fun time talking to you
Me
this whole
too.
time.
Thank you.
Yeah, so thanks a lot. Thank you everyone for watching, for listening. Yeah, we're here, we're on YouTube, we're on Spotify, we're everywhere. Follow us, subscribe us, like, hit the notification bell,
Ask
all the
questions.
kind of,
Contact us.
yeah.
So we are here to answer your questions. So
Absolutely.
reach
Check out
out.
Innocise.
Of course.
Yeah. And check out their cool Gecomer technology. They've got a lot of interesting videos also out there, demonstrations. Try to find them in a bar at 2 o'clock in the morning. Yeah, and yeah, check out
It's not
these
happening
Gecko
that
pens.
often anymore, but yeah.
Well, then see you.
Thanks.
On to
Bye.
the next one.